Hello everyone, I am Professor Jagadeesh Hugar. In this video, I am going to explain you the different types of openings, different openings provided on the pressure vessels, on the pressure shell surface. So basically these openings are used to input the fluids into the pressure vessels or to take the fluids out of the vessels. So pressure openings are designed based on the area compensation method. So opening is designed by the area compensation methods. So what is meaning of the area compensation? So you can see here, so this is the vessel cell surface. So this is the vessel cell surface, you can see. So here suppose this is here if you want to provide the opening. So if you want to provide the opening, so here you need to remove the material. Then only whatever the fluid that can go out are, so if you want to supply the fluid into this shell, so you can supply it. So when you remove this area, so this is area removed. So suppose if you remove this area, so that should be compensated. See, here you can say, so area here it is removed and same area it is provided here, it is added. So means here we have compensated the area whatever it is removed. So this method is called the area compensation method. So this technique is used in the design of the openings. So main opening is, in case of the pressure vessel, is that is nozzle. So that is designed based on the area compensation method. So here you can see this is the opening, that is nozzle, design of nozzle and openings in unfired pressure vessels. So this is the opening, so that is, you can say it is a nozzles. So this is the opening, this is the vessel cell surface, and afterwards, so this is the opening, means this is this opening portion is, this is inside the shell, and this portion is outside the shell. So this H1 is called the height of the opening outside the pressure vessel, and H2 means it is height of the vessel, height of the opening inside the pressure vessel. So here you can see, so this dn, so this is inner diameter of the pressure vessel. Dn means it is diameter of the pressure vessel, it is in uncorroded condition, means before corrosion is going to happen. So whatever the diameter, so it is dn. dnc means, so after certain days, after if you use few days, means some days. So after that, so the surface will get increased, means size will get increased because of the corrosion. So corrosion will going to remove the material from the surface. So this dnc, this diameter is represented by dnc, means it is diameter of opening in corroded condition. And afterwards, so Tn means it is called the thickness of the nozzle from this point to this point, and Trn is this is hatching portion from this point to this point. This Tn, this is Trn, T suffix Rn, means it is minimum required thickness of the nozzle. And here you can see, so this area is removed here, so it is represented by Ar to make the passage of the fluid into the vessel or to remove from the vessel. So this area is removed, so this whatever the removed, so here it indicates it is added area. So this is called the reinforcing pad. So this area is added to make compensation of this area. Okay, so here this TP means it is Sometimes it is denoted by T suffix PE, thickness of reinforcing pad. And you can see here, so outer diameter of this opening will be equal to the inner diameter of reinforcing pad. So this is important, you need to understand. Outer diameter of the opening is equal to the inner diameter of the reinforcing pad. Means from this point to this point, what is the diameter value? So it is equal to dn plus here plus t, here plus t. Here, sorry, it is tn, and from here to here it is tn, means it is 2tn. dn plus 2tn. So that is the outer diameter of this nozzle as well as inner diameter of the reinforcing pad. Again, next is TRS, means it is thickness of minimum required thickness of the vessel cell, and TS means it is thickness of the vessel cell. This areas indicates the, so what you can say, area that is need to, so that we shall see in the next slides, different areas. And this A, B, C, D dotted indicates it is the boundary within which we need to place the reinforcements. Suppose here it is reinforcing pad is placed. So this, it should not go outside this dotted line. Whatever the reinforcements, we should need to add within this boundary line. That is A, B, C, D. AB will be equal to 2 times DNC. So that whatever the symbols I just explained, dn means it is inner diameter of nozzle in uncorroded condition. DNC means it is inner diameter of nozzle in corroded condition. Di means it is inner diameter of vessel cell. TRN means it is minimum required thickness of the nozzle wall. TRN means TRN means it is minimum thickness of the nozzle wall. TN means it is actual thickness of the nozzle wall. TRS means it is minimum required thickness of vessel cell. TS means actual thickness of vessel cell. Eta means it is efficiency of welded joints in the nozzle. So H1 is height of effective compensation in nozzle wall outside the vessel cell, measured from outside surface of the vessel wall. So this already I shown in the figure, H1 and H2. So this is inside. Height of effective compensation in nozzle wall inside vessel, measured from inner surface of the vessel wall. So these are the different symbols that is used in the nozzle, that is opening. So design procedure, how to find the different dimensions of the nozzle. First one is estimation of nozzle parameters. What are the nozzle parameters? First one is inner diameter of nozzle in corroded condition. DNC is equal to DN plus 2C. Next is minimum required thickness of nozzle wall. It is given by TRN is equal to Pi into Dn by 2 sigma allowable into eta minus Pi. So here Pi means it is inside pressure, that is design pressure of the pressure vessel. Dn means it is diameter of the nozzle in uncorroded condition. Allowable means it is sigma allowable means it is allowable stress for the nozzle material. Afterwards it is eta means it is efficiency of welding joint. Pi means it is inside pressure, that is design pressure. Next is minimum required thickness of vessel cell. So this is minimum required thickness of vessel cell it is. TRS is equal to Pi into Di by 2 sigma allowable eta L minus Pi. So this two formula looks same, only diameter values are different here. Here it is Dn, here it is Di. Di means it is inner diameter of vessel cell. Next, fourth one, it is height of effective compensation in nozzle wall. H1 is equal to square root of dnc into bracket Tn minus C, or actual height of nozzle outside the vessel. So whichever is smaller, so out of these two, whichever is smaller value, so that we need to consider. Normally this value will be given in the problem. This we need to calculate. So out of the both values, whichever is smaller, so that value we need to consider. So same for H2. Use this formula, square root of dnc into bracket Tn minus 2C, or actual height of nozzle inside the vessel, whichever is smaller. Next is the reinforcement boundary limit ABCD is such that AB is equal to 2 dnc. So this already I shown in the figure, nozzle figure, opening figure. Okay, AB is equal to 2 times dnc. Dnc means it is diameter of nozzle, inner diameter of nozzle or opening in corroded condition. Second one is estimation of compensation. So first is area of opening in corroded condition for which compensation is required. So this is denoted by AR is equal to dnc into TRS. Okay, so this is the area of opening in corroded condition for which compensation is required. So here you can see this figure, AR figure. So this is AR means, so this is TRS, this is, from this is, it is dnc. So that's why this area is given by dnc into TRS. So this is the area calculated on projected area. It is a rectangular shape. Its area is given by dnc into TRS. So this is TRS. From here to here it is TRS. Next is area available for compensation is equal to AA is equal to A1 plus A2 plus A3. So these are the formulas for to find the A1 plus A2 plus A3. So this already notations are explained, so I don't go in detail of these. So once you find A1, A2, A3, just to make summations, you will get the value of AA. Once you find both area, then you need to check whether the reinforcing pad is required or not. Means compensation is required or not. Third one, in this third one, required area for compensation for required area of reinforcing pad. So how much area is required for the reinforcing pad, means what should be the dimensions of reinforcing pad. So suppose if AA is greater than or equal to AR. So here if AA is greater than or equal to AR, then compensation is adequate and no reinforcing pad is required, means no reinforcing pad is required. So reinforcing pad I have shown in the figure, so that will not be required if this is the condition. If AA is less than AR, then compensation is inadequate and reinforcing pad is required. Under this case, so reinforcing pad is required. Then area of, if this is the case, then area of reinforcing pad is given by A is equal to AR minus AA. Once you find area of reinforcing pad, then next step is to find the dimensions. So area of reinforcing pad is given by, in terms of diameter, outer diameter of reinforcing pad minus inner diameter of reinforcing pad into thickness of the reinforcing pad. So area you will get it from this previous one. Thickness normally it will given in the problem. DPI means it is inner diameter of reinforcing pad. So this will be equal to dn plus 2 times tn. So which is already I shown in the figure, that is outer diameter of the opening. So if you substitute, so you will get the outer diameter of the pad. So let us see one problem on this. A pressure vessel subjected to a design pressure of, so this is directly design pressure is given PI 0.75 MPa, consists of a cylindrical shell with 2 meter inside diameter, means Di value is given and thickness of the shell is given 10 mm thickness, and opening of inner diameter 300 mm, means it is Dn 300 mm, and wall thickness of 10 mm, means it is Tn. Tn is equal to 10 mm is provided in the shell. The corrosion allowance is 2 mm. Corrosion allowance means it is C value is given, it is 2 mm, and weld efficiency is 0.85, means it is a 85%. Weld efficiency is 85% or 0.85. The extension of the opening inside and outside the vessel cell is 15 mm. Means H1 and H2 both value it is given in the problem is 15 mm. The yield strength of material used for the shell and the opening, for both opening and the shell, it is made up of same material. Its yield strength is 210 MPa. So whenever yield strength is given, so factor of safety should be you should take it as a 1.5. A reinforcing pad of 10 mm thickness plate is provided. So whatever the reinforcing pad, if you use reinforcing pad, so its thickness should be equal to 10 mm. Determine the dimensions of the reinforcing pad. So here what we need to do, we need to find the dimensions of reinforcing pad. So here first what we need to do is, first we need to find the whether the reinforcing pad is required or not. So to find that, we need to find the thickness of the opening and vessel cell. Okay, so let us solve this problem. First, given data, let us see the given data. Design pressure is given PI 0.75 Newton per mm square. SYT yield strength is given 210 MPa. Inner diameter of vessel cell it is 2000 mm or 2 meter. Dn diameter of nozzle in uncorroded condition 300 mm. Thickness of vessel cell it is 10 mm. Thickness of nozzle it is 10 mm. C corrosion allowance 2 mm. Efficiency it is 85.85. H1A and H2A both are 15 mm. First we need to find the allowable stress. It is SYT is given, yield strength, so FOS is 1.5. 210 by 1.5, it is 140 Newton per mm square. First is estimation of nozzle parameters. So in that, first A, inner diameter of nozzle in corroded condition. So it is given by DNC is equal to DN plus 2C. So DN value is 300, C value is 2. 300 plus 2 into 2, it is 304 mm. Next, B is minimum required thickness of nozzle wall. This formula is given by TRN is equal to Pi into Dn by 2 sigma allowable into eta minus Pi. So substituting all the values, so you will get the TRN is equal to 0.95 mm. This is the minimum required thickness of nozzle, that is opening. Next is minimum required thickness of vessel cell. It is given by TRS is equal to Pi into Di by 2 sigma allowable eta L minus Pi. So here it is TRS is equal to, substitute again all the values. So you will get the TRS is equal to 6.32 mm. So whenever you substitute values, so you should need to concentrate more on the units. So if you made mistakes, so it will be very difficult, you don't get answer. So here you can see, if you want to substitute you should substitute all the stress and pressure values in Newton per mm square and diameter value in mm. Then you will get the thickness values in mm. Next is D, height of effective compensation in nozzle valve. H1 is equal to this formula you can use, otherwise, so this actual height of nozzle outside the vessel cell is given in the problem. It is 15 mm. Suppose if you calculate this formula, so DNC value is, it is 304. So 304 and this Tn is 10. 10 minus 2 is 8. 8 into 304, it is something, it is around the 2432. So square root of 2432. So this will be around 49 mm. So that's why here out of this we need to select the smaller one. So that's why, so whatever the given in the problem, so that is smaller. So that's why H1 is equal to 15 mm. Here also same, if you calculate this value, so this is more than 15. So out of these two, whichever is smaller, again if you take, so then it is H2 is also equal to 15 mm. Next is the reinforcement boundary limit ABCD is such that AB is equal to 2 DNC. It is equal to DNC value calculated earlier. It is 304. 2 into 304, it is 608 mm. Next is estimation of estimation of compensation. First one is area of opening in corroded condition. It is for which compensation is required. AR is given by DNC into TRS. It is equal to 304. TRS is 6.32. It is equal to 1921.828 mm square. Next is area available for compensation. We need to find the A1, A2 and A3. So these are all the values, substitute here. So you will get A1 is equal to 510.72 mm square. A2 is 211.5 mm square. A3 is 180 mm square. So total area that is available for compensation will be equal to the 902.22 mm square. So here you can see AA is less than AR. So next is we need to check whether the reinforcing pad is required or not. As the AA is less than AR, compensation is inadequate, means not sufficient, and reinforcing pad is required. Reinforcing pad is required because you need to support it. So that the area of reinforcing pad is given by A is equal to AR minus AA. So if you calculate this, AR minus AA, its value is 1019.06 mm square. So this is the area of reinforcing pad. So next step is we need to find the dimensions of reinforcing pad. Dimensions of reinforcing pad is calculated by using this formula. A is equal to DPO minus DPI into TP. So the DPO means it is outside diameter of reinforcing pad. DPI means it is inside diameter of reinforcing pad. TP means it is thickness of the reinforcing pad. So area just we have calculated 1019.06. DPO as it is. DPI means it is equal to DN value is given. DN is inner diameter of reinforcing pad will be equal to DN plus 2TN. So DN value is how much it is? DN value is given as 300 plus 2TN. TN is 20. 2TN means it is 20. TN value is 10. 2TN means it is 20 mm means 300 plus 20 it is 320 mm means inner diameter of reinforcing pad it is equal to 320 mm. So if you simplify this, so you will get the value of DPO means it is outer diameter of the reinforcing pad. Now we got all the dimensions of reinforcing pad. So main dimensions of reinforcing pad are outer diameter, inner diameter and its thickness. Outer diameter is 422 mm, inner diameter is 320 mm and thickness is 10 mm. So these are the dimensions of the reinforcing pad. So again you solve the different type of problems on this openings or nozzle from the previous question papers. So next is supports used for pressure vessels. Means suppose if you want to keep the pressure vessels, so you cannot keep directly on the ground. Means you need some supports. So that means you need to place them on the proper supports. So if you want to keep the pressure vessels in vertical fashion, supports are different, and if you want to keep the pressure vessels in horizontal fashion, then type of supports will be different. So these are the lug support and skirt support. So these are the used as a supports for pressure vessels when you want to place the pressure vessels in vertical fashion. So I don't go in the details. So you just go through this in this books. So you just prepare the questions. This is easier, not any much difficult here. So you study this different type of supports. Next is saddle support. So this type of supports are used when you want to keep the pressure vessels in horizontal fashion. Okay, so these are the different type of supports. Normally in exam they will ask in the theory question, so explain the different types of supports used in the pressure vessels. So next is, these are the important theory questions from exam point of view. So you just prepare these questions. Explain different types of stresses induced in the cylinder. Explain the assumptions made in the analysis of cylinder. Means explain different type of stresses induced in cylinder. 3 types of stresses. What are those? Longitudinal stress, tangential stress and radial stress. So when you make the analysis of thin cylinder, so you are going to assume no radial stress and tangential stress is constant. So you just explain that assumptions. Derive Lehm's equation. Explain under what condition it is used. So Lehm's equation, that is equation to find the thickness. So that is Lehm's equation. So explain under what condition it is used. Means when we can use Lehm's equation to find the thickness of the cylinder. So it is based on the maximum principal stress theory. So maximum principal stress theory is applicable for only brittle materials. So means whenever there is a brittle materials, then we can go for the use of Lehm's equation to find the thickness of the cylinder. Explain different methods of presetting in cylinders. So prepare these theory questions. Draw the stress distribution in compound cylinder and how it helps to increase the load carrying capacity of thick cylinder. So this figure and question you should need to understand very thoroughly, because this is very important from concept point of view also, to solve the problem also, everything. Means you need to explain how the stress is going to distribute in the compound cylinders and how it will help to increase the load carrying capacity. So this I already explained in detail in explaining this theory. Next is explain with neat sketches various categories of welded joint used in the pressure vessels. So prepare this theory question also. Next is explain with neat sketch different types of formed heads. used as end closures in cylindrical pressure vessels. So prepare this question. Different type of end closures. Okay. So that is 4 to 5 end closures are there. So you just prepare that question. You just need to prepare the figures. You need to prepare that formula. That is different formula, means it is thickness formula. So and its advantages and disadvantages and applications. Next is draw the neat sketches of supports used in the horizontal and vertical pressure vessels. So you just prepare this from the books. So different types of supports, means in horizontal and vertical pressure vessels. So thank you all for the watching this video. So here now I am going to close this. So prepare all the questions. So you just go through the different question papers from the previous year question papers, university question papers. Prepare all the questions. So if you have any doubts or any queries, so you can contact me. So I want you to ask some doubts. Then only I can understand that you are doing something or you are studying. So if you have any questions, so you are most welcome to ask the questions. Thank you all for watching this video.